Okay, in this video I'm just going to take you through the running of one of the little practical stepper motors that we got here at the college. And this stepper motor's got four phases and a basic step angle of 7.5 degrees. And we're going to look at how we can switch that in two different ways, so we can actually run at 7.5 or reduce that step angle to 3.75 degrees. The coil arrangement on this motor has got the coils centre tapped to a common. So each coil is centre tapped to a common, and then it works by, when the switching arrangement is changed, it either turns the half a coil off or effectively reverses the direction of current through the coil. So if this switch is in this position, current's going down here through that half of the coil in that direction. If we switch it down to this one, the current's going through this half of the coil in the opposite direction, effectively reversing the north-south poles. And the same with the bottom pair of coils here. So we can get these north-south poles to change over in a sequence and drag the rotor around, as you may have saw in the other video on the introduction to stepper motors. The two different stepper sequences for this motor. The first one's a four-step sequence where there are always two of the motor inputs turned on at a time. So we step from step 1 where we've got 1 and 2 on, we turn 1 off and 3 on at the same time, and then we turn 2 off and turn 4 on, and so on, around a 4-step sequence. That one's not achievable with the hand switches that we're going to look at first, but you'll see that one running with the software on the little microcontroller a bit later. And then if we want to change that to a 3.75 degree per step, we can do an 8-step sequence where only one bit of the inputs changes at a time. So we got a double 1 here. We turn 1 off first and it will step 3.75 degrees, and then the next step is to turn 3 on, then turn 2 off, then turn 4 on, and so on, and we end up with an 8-step sequence before we come back to the top here. So what we'll do now is take a look at some little videos that show how this step sequence will make that motor work.
Okay, so having looked at the circuit diagram, the layout of the stepper motor borders looks like this. We won't worry too much about these electronic components in here used for the switching. We've got a motor here, we've got a black mark on it so you can see it going round. Power supply of 0.5 volts on these two terminals here, and we got the 4 input terminals 1, 2, 3, 4, and we're actually applying the logic 0 to those, which is then inverted in the electronics. Then what we've got is set up over here with 2 changeover switches. So switch in the up position feeds to here, the common terminal in the middle, changing over to there. So as we move this switch, we'll get a logic in the current switch position, both switches up, we've got logic 1 on both inputs, logic O on both inputs 1 and 2. So the sequence that I'm able to do with these switches is the 3.5 degree per step sequence. So as I switch SW1 to the central position, I've taken the input off number 1, and so we're now currently 0100. Then I switch that so the input 3 comes on, so the next one in the sequence, and then the other switch is switched, and as you can see with each step of the switch in that sequence, the motor steps round one step in its cycle, and I'm now back to the 1100 input. If I start going in the opposite direction, operating switch 2 first and then switch 1, the motor goes in the opposite direction, and the faster I move the switches, the faster the motor goes. What do you think of my little tripod? I think that come out of something like bloody Poundland or something similar.
Oh yeah, I've seen. That's very good.
I tell you, that's handy if when you're on holiday and you want to take a picture and there's only, you want a group photo and there's only,
Yeah.
you know.
Yeah, I went a bit further on this.
We ain't got anything PLC wise with transistor outputs, have we? We ain't got nothing.
Yeah. Siemens.
Siemens a transistor.
Well,
What about the
four of the Siemens and
Allen Bradleys?
can't remember, they might be.
Because they still ain't give us the bloody software for them, are they?
No, the Allen Bradleys are transistor and I've put relays on. No, I have to get this.
The Allen Bradleys are transistor,
Yeah,
but you'll put relays in between them and the,
yeah,
which makes sense for kids, doesn't it?
yeah. I thought it was just a good idea.
Yeah.
The
Key switch to bypass them would be a nice idea.
yeah. Yeah, we've got Siemens with,
Wasn't it?
yeah, I can't remember, but the little Micrologics, are they relay? Can't remember.
I don't know anything about them. I don't really know how to program Siemens. I get away with, but none of it. We ain't got nothing Mitsubishi this transistor, have we?
No, we'd have to buy.
Buy what? I'll tell you what. How you could get away
Well,
with it.
we
You
need-
could buy an extension, couldn't you?
We-
With
Transistor.
4 transistor outputs on.
Yeah,
They are.
the adults.
Yeah.
I'll have a look.
I don't.
We need another FX3G, and I could get that as.
We do, and we need it pretty quick, really, because I've got 20 in that group I'm teaching at the moment. In fact,
I'll
I
have to
might
put a
even be
1S
21.
back then.
Yeah,
I've got some 1S's too.
but we had trouble with them, didn't we? That's why I paired them up, didn't I? Because halfway through the bleeding session, we were having no end of trouble.
Yeah, they've changed the build on the laptops.
Okay,
So we'll have to find out
Yeah.
whether, because you know what they've done anyway, they've used an image, not with the proper drivers on, they've changed this now. They used an image, not with the proper drivers on, and then put the other drivers on, so they get confused dead easily, which is why we get blue screens on log on sometimes. Because they can't find the right drivers, it's got it round its neck. But that's because of them putting a crap image on. I mean, everybody knows the hardware screws up every day.
Right, so what we've got here now is a little bit more sophisticated setup, where the stepper motor board is connected via a patch board to a little Genie microcontroller. Something that you'll become a little bit more familiar with when we look at control systems in Learning Outcome 2.
Okay, so this is the the first program we're going to look at with the control of this stepper motor, the Genie software. I just used a switch to turn it off and on, and then these output sections turn each input or pair of inputs on and off, or 4 inputs on and off through the sequence. So the first one has got input 1 and input 2 turned on, 4 and 5 on here because of the output arrangements were used. The next one in the line turns input 1 off, and then the third one in the line turns input 3 on, leaving input 2 on, and so on. That will go through the sequence. What we're going to do initially is allow that to run quite slowly so that you can see the program stepping, and to do that I'm going to run that in the debug mode so it runs quite slowly. Once we do that, we find that if we put the D1 switch on, it starts to step through the program, and now we'll take a look at what the stepper motor is doing. Okay, with this version of the program, we're still running in slow debugging mode so you can see what's going on, but I've taken out every other step in the sequence. So now we've got a 4-step sequence where there's always 2 outputs on at a time, 4 and 5 here, 5 and 6, 6 and 7, 4 and 7, and back to the start. This should have the motor running in 7.5 degrees per step. So we'll take a look at that now.
So we can see that with that program running effectively with a 0.1 of a second clock pulse, the sequence is going a lot faster than it was before. At the motor we can still see some discrete steps but it's running quite smoothly. And the idea here is that if we counted the number of steps that we move, we could actually move to a particular position around that circle, or move something a particular distance.
Okay, now in this version of the program there's an attempt to show how the motor can be run a little bit faster and how the speed can be varied. Each of the steps has had a 0.1 of a second delay set between the steps in the program. So we'll take a look now at what that does at the motor end, and then we'll try and see if we can get it to run a little bit faster and a little bit smoother with another program.
So here we go. If we look at the Genie board output indicators now, there's always 2 of them on at a time, and it's a 4-step sequence, which sees the little stepper motor running in 7.5 degree steps, and there's 4 for every 30 degrees. So if we take a look at the Genie microcontroller board now, we can see the with this program running, it's running quite slowly, and you can see it go through the 8 steps in the sequence on the Genie board output indicator lights for a 3.75 degree per step operation, this motor. And if we look at the motor itself, we can see it going round quite slowly in small 7.5 degree steps.
With this last program, what I've done is set it up so that the delay between steps is 0.02 of a second, or it's a 50th of a second clock and pulse, and we should see now that the motor's running a lot faster and more smooth, and you can't really see the discrete steps.
So here we can see the Genie board outputs running with the 0.02 second delay, or on a 50 Hertz clock pulse. And if we take a look at the motor now, we can see that it's running a lot more smoothly, and it's very difficult, if not impossible, to tell that it's running in stepper mode. If we were to reverse the sequence of that it goes steps through, then the motor would go the other way, but I'm going to leave that for you to perhaps investigate later on in the module.